Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. This is episode number 162. On this episode, we'll dive into the world of electronics testing with an expert within the electronics testing industry, Robert Boguski, president and owner of Datest. Robert brings 44 years of experience in the design, fabrication, assembly, and testing of printed circuit boards and electronic systems. Under his leadership, Datest has become a premier provider of advanced integrated PCBA testing and inspection services, serving both contract manufacturers and original equipment manufacturers since its founding in 1984. Robert's extensive background includes active participation in industry associations such as APICS, SMTA, and IPC, reflecting his commitment to advancing the field. He is also a columnist for Circuits Assembly magazine, where he shares his insights on industry trends and challenges. In this episode, we'll explore Robert's journey in the electronics manufacturing industry, the evolution of testing technologies, and his perspectives on the future of electronics testing. Join us as we gain valuable insights from a leader whose career has been dedicated to excellence in electronics testing and manufacturing. Stick around. I'll be right back.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Rob Boguski, welcome to Reliability Matters. Thank you, my friend, for coming on the show.
Hi, Mike. Good to see you.
Great to see you. Rob, what made you decide to leave whatever you were doing 40 years ago or so and purchase a testing company within the electronics manufacturing space?
It was all about the money, Mike. Get rich quick and retire as soon as possible.
There's so much money in this industry to be made, right?
And then do what you really want to do, opining about the world from the comfort of a desert island with an umbrella drink.
Yes, exactly. I'm talking to you from my private island in Tahiti right now.
Fiendishly clever. Seriously, family pedigree. My family, 2 generations, have been involved with electronic packaging and manufacturing going back to the 1950s. My father graduated from Lehigh University in Bethlehem, Pennsylvania in 1956. And he went to work straight out of college for a company called Photo Circuits in Glen Cove, Long Island, New York, which was one of the original merchant bareboard fabricators. In those days, building radio boards for the likes of Delco Radio for GM, building guidance system boards for ICBMs, for various defense contractors in those days, and started in New York, expanded to the West Coast, which is how I ended up on the West Coast in California. My family migrated in 1960 from New York to Orange County, and my dad ran Photo Circuits Anaheim operation for a number of years until someone left a reflow pot on one evening and neglected to turn it off before going home. And sometime during the night, it ignited the roof. And that was the end of that. So.
Wow. Oh, what
easy come, easy go. And
hard come, easy go. Yeah.
Yes. But my dad, after that, had many different positions in printed circuit manufacturing as well as component manufacturing over the decades, and I kind of caught the bug from him. He started his own business in 1975 when I was in high school, and I naturally learned the trade there. The intent was not to stay in the business, it was just to have something to fall back on if all else went to hell. But then when I graduated, I had an academic path in mind, and for a lot of reasons that didn't work out, and I ended up staying in the business and learned that trade, determined I was pretty good at operations management, and acquired experience and knowledge in the School of Hard Knocks, and stayed at that for almost 22 years. And then from there, spent a number of years in electronic manufacturing and assembly, kitting, uh, box build manufacturing, turnkey manufacturing, and then with two partners acquired Datest in 2005. We were actually customers of Datest at the time and had certain customers who needed in-circuit testing performed, and Datest was supplying that service for us. And the then owners wanted to unload it. They had their own financial issues and didn't want to own Datest anymore. So we acquired it at a very attractive price. And that was 2005. And then 2009, I bought my partners out, and they bought me out of our other business, our manufacturing business, and we went our separate ways. And in, I guess it was July of '09, my wife Regina and I became the owners of Datest, and here we are today.
Wow, no looking back.
Nope. Nope, and that's the Reader's Digest version of a very long multi-volume story with some advances, some setbacks, and lots of battle scars to show it.
Yeah, I think any entrepreneur definitely wears those scars proudly, actually, because it forges who you are. What types of testing does Datest offer? And could you walk me through some of the options like flying probe testing, X-ray inspection, boundary scan, et cetera, et cetera?
Datest is a full-service electronic testing and engineering company. When it was founded by the original owners in 1984, Datest focused exclusively on in-circuit testing using Teradyne Zentel and eventually Genrad and eventually HP Agilent Keysight equipment. So things like Genrad 2287s and things of that nature, Keysight 3070s. And for those who can really date themselves, Fairchild Zentel 303 machines, which are 70s era almost vacuum tube technology testers. Since I've owned the company, we have augmented those services, adding to the ICT repertoire flying probe capability, boundary scan capability, what's known as AXI, which is an acronym for automatic X-ray inspection, basically robotic X-ray inspection of solder joints. And then also we've created, by customer demand, really, failure analysis business involving imaging technology. So what's known as 2D X-ray, 3D X-ray, and CT scanning, digital tomographic imaging. And from that, today, not only do we do failure analysis on printed circuit board assemblies, still our bread and butter business, but we do imaging of all kinds of other interesting things. And maybe we can get into that later. But once you set up shop and say you've got a great big CT scanning machine, there's no telling what somebody will bring you and ask you to scan it for them. And it actually is the interesting part of the business, because something new comes in and we all gather around and go, cool, this is really neat. We're going to learn something here.
Yeah, I was going to ask you this question in a little while, but since you brought it up, you talked about in-circuit testing and flying probe testing. Allegedly, there's a false technical equivalence between those two types of tests. What are the differences in those specific types of testing methods? And do you encounter this in your day-to-day dealings with clients, kind of the false equivalence? And if so, how do you address that?
In simplest terms, in-circuit testing is a digital test, and it requires dedicated test points on the board in order to access the board in the first place. In equally simple terms, flying probe testing, basically understood, is an analog test. It is advantageous in the sense that you do not need dedicated test points to access the board. As long as there is metal that you can drop a probe on, you can test the board. The problem comes up, the flying probe manufacturers, and there are many, and bless their hearts, they want to sell machines. So they try in their marketing to say, we can provide you with the machine that will do all the things that ICT does just as easily for less cost. They come close. They come asymptotically close in many respects, but it is not equivalent. Number one, first and foremost, it is not a digital test. If you want to perform a digital test on a flying probe machine, yes, you can augment it with other things like JTAG boundary scan and other techniques and other methodologies to come close and maximize coverage. But they're really two different things. ICT is suited for high volume manufacturing. Flying probe is most suitable for the so-called high mix, low volume type of manufacturing that we're known for, particularly here in the States. Defense related, aerospace related work, medical related work, where you tend to have many different revision changes, many different bill of materials changes, where it becomes prohibitively expensive to redo an ICT fixture every time. An ICT fixture and program, dollars, you're typically looking at a 5-figure sum of money for both the program, the hardware that goes with it, the interface between the tester and the board, and the program that the engineer has to create and then debug to that board. Whereas with a flying probe, you can create a program relatively quickly, often less than a week, often much less than a week, and be testing boards much quicker. But the coverage is different. The techniques are different. The access means are different. And the overall methodology is different. So I have to spend a lot of my time just educating customers. This is what you want. This is what it'll do. However, for a lot less money, you might want to consider flying probe, especially since you've revealed to me your design is in its infancy, so you have a very high risk of changeovers and multiple revision changes, and you want to keep your changeover costs to a minimum. This might be the better path for you, at least in the initial phases of your product development. So that has to be explained.
Flying probe when things are in development, there's a lot of things are changing, and then ICT when a product is mature and not destined for multiple changes. Is that
Yes.
kind of the snapshot? Yeah.
Yes, that is the snapshot, but you also have to take into consideration the design. And one of the things we offer as an engineering service and as a screening mechanism is some software tools that will look at a customer's design at the beginning. We'll take CAD files and analyze them for the customer and run a bunch of what-if scenarios. Let's say they are interested in ICT. We'll tell them using this software, this is how accessible it is at this stage in your development. Maybe it's 60% accessible or 80% or 90% or whatever the case may be. And we'll provide them with a report, a net-based report telling them this is how good or bad your board is from a testability standpoint. And then they can make some informed decisions which direction they want to go.
And that's relative to flying probe as opposed to ICT.
It's actually relative to both. If they're contemplating flying probe, we can analyze their design with that assumption and come back to them and say, well, Ms. Customer, your board is only 60% accessible, assuming you employ ICT. Either go back to the drawing board and refine your design, or if you're going to hold on that design, then we would recommend you not spend the money in ICT, that you go in the direction of flying probe for this revision. It's a far better use of your money at this stage. And
or just make sure that all of your defects are within the 60% contact range.
Right, easy to do.
Easy to do. You mentioned contact, which brings up another question I was going to ask later, but to keep it in context, obviously metal has to touch metal at some point to conduct that type of test. Back in the 90s, the industry thought it would be a swell idea to stop cleaning boards, and by use of the no clean flux technology. And a lot of that's changing today due to miniaturization and other factors. But how important is it to have a surface that, when metal touches metal, that it's actually touching metal and not some kind of residue? Do boards reflowed with no clean flux and then not cleaned present a challenge of any sort to these types of testing procedures?
I can't think of a better way to grind an entire testing process to a complete and total halt.
There's the answer. Yeah. It's important, obviously, to have continuity.
Think chewing gum on a board. And using flying probe as an example, you have, depending on whose machine you're using, you have anywhere from 2 to 24 probes moving around the surface of the board, top and bottom. And the whole premise of the test is to make contact with a conductive path. And when you land a probe on a board and you ground it, you're creating a conductive path. Well, if you have any kind of an obstruction to that, such as no clean residues, the probe is going to make contact with that, and more often than not, you'll get a false open. It'll declare an open circuit there. And then somebody has to verify that. That's where the troubleshooting comes in. Somebody has to look at that, compare it with the data, compare it with the schematic, compare it with other boards in the lot, and decide, is that a legitimate fault or not? Imagine a large board. Think of a board that's, let's say, 12 by 18 inches. A lot of nets, 3,000, 5,000 nets on it, a lot of solder joints, probably 10,000 solder joints top and bottom. Imagine no clean residue all over that board. You can literally, in that instance, have hundreds and hundreds of false opens, and they have to be confirmed or denied one by one. And so that's usually when the customer gets the call from us saying, guys,
it's cheaper to clean it.
Yeah, you neglected to tell us you were using no clean. So that 3-day lead time we signed up for, we're officially unsigning up for it. And
invisible ink. Yeah.
And oh, by the way, we'll see you in a couple of weeks, because that's how long it's going to take us to look at your 25 boards and decipher what's good and what isn't. And there'll be a secondary charge for that. And oh, by the way, we charge by the hour. So yeah. I hope you don't mind if we run some credit checks on you and little exaggeration, but you get my point.
I get the point. Yeah, absolutely.
Customers rarely inform you they're using no clean. Usually we find out in the doing, and that's when the indignant call goes and says, guys, either you take these back and clean them again, or we're going to be here for weeks. Yeah. And that has happened.
Interesting. What are some of the, besides residues that make testing unreliable, what are some of the most common issues you encounter during circuit assembly testing, and how do these affect the overall product reliability?
If I were to Pareto-wise the defects that we see in board level testing, the largest far and away is assembly workmanship. That could be things as simple as insufficient solder. It could be bridging. It could be opens. It could be lifted lands, tombstoning, polarity issues, all of the above. And automation has only made the incidence of those defects increase, in spite of all the checks and balances built into pick and place systems these days. We still see a lot of it, and it is still the most common origin of defects. We don't see a lot of design related issues. We see very few fab related issues. There's a tendency when something fails to blame two things: A, the bare board, and B, the BGA, which is usually the highest density component on the board to begin with. And that's where they want us to look in the case where there's failure and where they want troubleshooting from us. But yeah, it's usually assembly workmanship, even now.
You and I are in a similar situation with our businesses. I'm in the cleaning world, you're in the testing world. And in the cleaning world, we have to provide quite a bit of education because what the customer expects when they read the jar of Flux, it says no clean. They hear that as don't clean, and then they follow the instructions, and then there may be issues with electrochemical migration and all that. And sometimes they're fighting a reliability issue. They don't understand where it came from because they ran everything according to the manufacturers, the solder material manufacturer's specs, the oven profile was right, et cetera, et cetera, et cetera. And now they're having problems. So we have to do a lot of education before we can even talk about our products. I think in your world, it might be similar because a lot of manufacturers realize they have a problem. They don't even know what type of test to search for that problem and what would be the most appropriate type of test for the problem they're having. So if you were to divide up your working day by the day or week or month, how much of your time is spent just educating your clients in the diverse array of test methodologies, and how much of your time is spent merely setting realistic expectations? You know, how much education are you in your industry do you have to provide just to get as close to parity as possible so that the customer has the proper expectations and understands the proper test protocols for, that would meet their overall expectation? Does that make sense?
Yes. The short answer to your question is probably half my time. The long answer is not only do I have to educate them, but I have to screen their requests from a viability standpoint. We are viewed as a black box performing this one thing called testing. It doesn't matter whether we do that testing or not. For example, you're in the cleaning business, you do ROSE testing, or you have colleagues who do ROSE testing every day of the week. We don't do that. Nevertheless, we get asked, do you do ROSE testing? Do you do C3 testing? Do you do thermal cycling? Do you do Haas and Halt? Do you do drop testing? Do you do Vibe? Do you do peel testing? I had a customer a week or so ago who wanted leach testing. They had a certain solder composition, a very exotic solder composition for an aerospace application, and they wanted to do destructive testing, cross-sectioning of a board, to determine whether there had been any leaching from the joint itself into the substrate. And this requires some pretty sophisticated chemical analysis involving SEMs, involving EDS, EDX technology. And again, we don't necessarily do that, but we have an ecosystem of partners whom we work with very closely who do that. And I can refer them to people who do that, or I can act as a project manager and for convenience sake, take the PO and then use the ecosystem as my subcontractors. And some customers are very comfortable doing that. So we get involved in situations like that. In other cases, recent example, customer, very well-known name, you would recognize it immediately. Large company has a functional test of a certain product that was developed by their engineers on their bench in their lab at the prototyping phase. Works okay, but it's a manual test. So it's a onesie, twosie, plug in, plug out type of thing, apply power, take readings, record data. They're now moving into production and they want to automate that process and make it very robust for production so that it can be deployed at their EMS company and used over thousands of boards robustly and reliably. and they wanted to hire us to take that basic manual design and convert it into an automated design. And it became very clear very quickly in the first meeting with them that they had no clue the amount of money that would be required and the time that would be required. So I did what I often do in those initial engagements. I threw out a number and a time to literally scare the living daylights out of them as a screening mechanism to determine, are you guys real or not? No disrespect, but this is what it's going to take. And so in this instance, I said, start at 100 grand and 6 months. And I then listened for the sound numbers. I listened for the sound of impact on the floor. And I know,
did you hear it?
I heard a lot of gulping. There were several engineers, and these were young guys, energetic, enthusiastic guys, very bright in their field, but had no concept of what this entailed. And I said, everybody's busy right now. This is what I think it's going to take. And this is just a shoot from the hip estimate. When we really get down to it, if you're serious about doing that, it could be more and it could take longer, but you need to be prepared for that. So if your management asks you, this is what I think is real, and you need to schedule accordingly. And the realists accept that and work with that. The idealists, or the people who are behind in the first place, who think you're going to be the savior who's going to pull them out of a hole of their own doing, they don't accept that and they move on to somebody else. They say thank you very much, and you never hear from them again. So it takes all kinds. And to come back to your original question, a lot of what we have to do is screen what's real from what isn't real, because this is serious engineering. Once we engage, once somebody signs up, then I'm going to assign engineers to the project, and they could work on it for months. And we want to get paid for that. I mean, we are not in business as a charity just yet, perhaps someday, but
no pro bono.
Yeah. There you go. We do have bills to pay. We do have families to feed, and we like that, and we're obliged to that, whether we like it or not. So once the switch is thrown, it means a whole lot of things. And so you don't want to waste people's time. You don't want to disrespect the customer and waste their time. And you certainly don't want them wasting your time as a supplier, because that's opportunity cost. And if you lose it there, it means you're not going to be able to recover it somewhere else.
On the subject of not wasting time, your company actually kind of morphed into two, I don't know if it's two companies, but two emphasis. One is testing and the other is failure analysis. And I think the investment in failure analysis probably nets an overall savings in time. So you're not just looking for problems, you're helping them avoid the problems that you're finding when you look for them.
Yes.
What was the rationale between kind of dividing up the company into testing and failure analysis? Because those are two very different specialties, right? Whole different skill sets there.
Yes, they are and they aren't. The failure analysis business was kind of a natural evolution out of the testing business. We had been in the testing business from 1984 to 2009 when Regina and I acquired the company, and it became evident very quickly that customers, engineers, wanted more answers than just your board failed. We tested 100 boards and 95 passed and 5 failed. We noticed right away that customers would press us more, go beyond the 5 failures. Okay, we see that they failed these bad components, or some cursory issue was described relating to workmanship. They would say, okay, now tell me why. I want the ultimate root cause. There's a solder splash. Is it excessive solder? Is it foreign objects or debris, FOD, on the board? Is there possibly a weak joint there? that's barely holding on, incipient reliability issue. And there was a significant volume of those questions, which gave us pause and caused us to think maybe we can augment what we do and offer this as a separate service, not only to our testing customers. It could move from the testing room into the imaging and failure analysis room, but we could also market the failure analysis service to other customers who may not even be using our test engineering services, but still have a problem and need help. And so that's what happened. We acquired our first X-ray system in 2009 and 3 other X-ray systems since then, various sizes, various powers, various capabilities to answer those sorts of questions. So now we can support both our testing business and also as a standalone service. Customers will call us up and say, I've got this board, I've troubleshot it on the bench to, U5, U6, and U13. Can you please provide me with images of those 3 devices, ignore the rest of the board, tell me what you see. Or another one, they've got the same X-ray system we have, they've looked at a board or they've looked at a lot of boards, they look good, but as a sanity check, they're going to send us one board. Would you guys please inspect this on the identical system to ours and tell us what you see? We had one classic case where we did that one time, and the board they pronounced good, our operator within less than 10 minutes found opens and shorts all over the thing. So I'm not sure what they were doing, but that's what happened. And the other outgrowth of saying, hanging out a shingle that you have a failure analysis business, people bring you other failed items to X-ray, and they are not necessarily circuit boards. We've done items like additive manufactured parts, welds, rocket nozzles, flex circuits. We've done organic materials. We did a fossil one time. We've done citrus fruit as part of a study by a local university. And probably the big kicker, last year we did human blood vessels. We actually CT scanned human blood vessels to assist a medical company in clinical trials. That was a real educational experience for us, because we offer our services as imaging experts, and we learned some lessons in anatomy and physiology. And in that case, we're sincere to the customer. We say, you teach us something, we'll teach you something. And if you're willing to work on that basis, then we can see if we can fashion a process and a business together. And in that particular instance, we were very successful with it. So that's what makes it fun.
One of the things that probably doesn't make it fun is when you can't duplicate the problem. In my world, in the contamination removal world, we have a phenomenon where everything works well in the laboratory and in the testing lab and in QC and all that, and then they send it out into the cruel, harsh world, and things fail. And then it gets returned back to the testing laboratory, and they get the dreaded NTF, no trouble found, which, by the way, it reminds me, my friend and colleague Doc Brown says we should not use the acronym NTF. We should call it TNF, trouble not found, because no trouble found is like diagnosis. Nope, nothing wrong here. Look somewhere else. Trouble not found acknowledges there's trouble. We can't find it yet. I think there's an even more appropriate acronym. It's WTF, because that's frequently expressed when the customer says there is a problem and you're saying there's not a problem. So in my world, that's exacerbated by harsh environments, moisture, parasitic electrical leakage, which you can't see, but you can measure only in certain circumstances. It comes and goes. Is that type of issue ever a problem where the customer sees there's an issue, you can't find it because the climatic environment is different? Do you have to test under harsh environments? Do you have to put it in a heat and humidity chamber in order to find the problem, or is everything tested in ambient controlled environments?
What we do is primarily ambient. However, by experience, we sometimes will ask the customer what the operating environment was to get a sense of the stresses and the loads the part is
There you go.
experiencing. Space flight is a very good example of that, where you've got an avionics module of some sort, a guidance system, that's going through multiple G forces at launch and at reentry. And nowadays, with the commercial space flight ventures going on, the focus is on reusability. How often can that module go back up on another mission? So sometimes we get involved with helping to do those evaluations, provide data to the OEM to help them make a determination whether the unit is suitable for one more mission. We'll do that a lot. Another case that comes up, they think a certain device has failed, and I'll go back to the BGA example. Everybody always picks the BGA. It's frequently the highest.
Yes.
Yeah, it's the highest density component on the board. Sometimes
The highest density
it's high
component,
density.
none of which you can see, right? The solder joints, they're all hidden.
So the default is it must be that. Well, again, by experience, we have found it behooves us to look just a little bit beyond the BGA, because sometimes we find the defect adjacent to the BGA. Other times we've actually found the defect on the opposite end of the board, something they didn't even consider, but it's there. And they get tunnel vision. They tend to think certain things and stereotype certain stereotypes without considering the larger picture and looking at the whole amount of stresses that the board is subject to. And so we often do that whether they know it or not. Just, it protects us, and it also, if we do find something, it opens their eyes as well.
Yeah, they get, I forget the psychological term for it, something to the effect of like expectation bias. They're used to that BGA commonly being a problem, so that's going to be the problem.
Exactly.
And to the exclusion of other things. That happens a lot in the medical industry as well. You talked about asking questions about, in what environment are things failing to help guide you toward a test, which kind of brings up this question. I would assume that there is quite a bit of tribal knowledge required in your world. You have to have, in many cases, it helps to have seen this problem before. It helps to ask probing questions, to prove or disprove a theory that's in your head. Given the fact that when people graduate university with double E degrees, for example, that doesn't make them automatically qualified to work in a testing laboratory. They may know how electrons work, but they may not know, the contextual elements that commonly result in reliability issues. When you're looking at hiring engineers, technicians to work in your testing laboratory, how do you how do you evaluate them in terms of their intelligence, obviously, their aptitude, theoretical skills, and there is a labor shortage, clearly, and a lot of that, we can talk forever about some of the causes for that, new generation, old generation, whatever. But without going down that road specifically, how does the labor shortage directly impact your business? And do you think it's more difficult to hire talent in your industry than other parts of the electronic assembly industry?
It is, because we compete against them. We compete against, here in Silicon Valley, we compete against the big names. People want to go to work for Google or Meta or Amazon or Apple or one of the AI startups in San Francisco because they're making cool stuff. And let's be honest, you go to a startup, the startup hits pay dirt. If they have stock options, then they're very wealthy in a very short time. We're a small business. What we do is kind of under the radar. It's a very essential function that we perform. It's not glamorous by any means. So we have to go to universities, find promising students. They may be double E's, they may be material science students, they may be mechanical engineering students, they may be none of those things. They may just be very bright, have an interest in understanding the way things work, tearing things apart. How many stories have you heard people got their interest in engineering because as a kid, they tore a transistor radio apart and then tried to put it back together again just to prove to themselves they could do it and understand how it worked. We like people like that. So they need to have some natural curiosity about how things work and why they failed. And two, some native intelligence, some ability to think their way out of a box on their own, given some guidelines. That could be an English major. That could be a very bright high school graduate. I'm not big on written credentials. I don't really care. I'm about the person. I want to meet them, understand them, and see if they have interest in us and we in them. And really, the academic credentials are secondary. If they have the drive, the intelligence, the aptitude, that indefinable thing, you know it when you see it, then you go to the next step and say, okay, here's what we do, here's what we can teach you to do, here's what you can learn if you apply yourself. Does that interest you? And for that one person out of maybe 25 that we talk to that is interested, that's the kind of person we want to hire. It's a long search. It's a needle in a haystack search, kind of like what we do in our failure analysis business some days. But that's the person we're looking for, and we're always looking for persons like that, regardless of the state of the economy. You have to keep the pipeline flowing.
Yeah. I'm certainly not a failure analysis engineer, but within my company, particularly in the early days when I was more involved, when I was a little bit more of a chief cook and bottle washer, doing everything, I was always really good at failure analysis within our product. A customer would call, and it wouldn't take me long to diagnose the problem. Well, I designed the equipment, so I have a leg up there. But the way I look at diagnosing a problem is I reverse it. I think to myself, what would I have to do to cause that problem? If I wanted to play a trick on my associate, if I wanted to punk them and make something fail just for fun, what's the best way to do that? And, well, if I unplug this wire, this will happen. Okay, well, that's what's happening, or whatever the case may be in simple terms. So I was trying to reverse engineer the problem rather than just looking at everything, testing everything. I just think, what if I wanted to do this? What if this was intentional? What would I have to do? Well, there's three things that would cause this. Okay, what's the most likely? And just kind of go down. To me, that's less engineering skills and just more common sense, more common sense applied to it. So I think in your world, particularly in failure analysis, there has to be a little bit of that inquisitive curiosity is the word you used. Maybe even skepticism to listen to the customer, but not take everything at face value. I can't tell you how many times I've been on the phone with a customer and I'll do the real obvious thing. It's like, okay, have you checked to make sure the sensor is plugged in? And I always hear, yeah, we've done that. Have you rebooted the computer, like the cable company? Have you rebooted? Yeah, I've done that. And maybe 50% of the time, that might be a little exaggeration, but not far off. They didn't. They just figured, well, obviously, yeah, whatever. And nope. I no longer automatically check that off my list. I just say, customer said yes, but I don't take that as gospel. And I remember once I was talking to a customer, they were on the East Coast, I'm on the West Coast, and I asked them to check A, B, and C, and they did. And in my head, I'm like, I cannot figure out why something's not working. If A, B, and C are correct, this has to work, right? It dumbfounded me. So they ended up writing us a purchase order. I flew out to the East Coast, and I found out it was A. The answer I got was incorrect, and they could have. It was something almost as simple as they could have just plugged something back in, or replaced a fuse, or something like that, and they didn't. And we sent them an invoice for round trip tickets and per diems and hotel and labor costs and all that, and they refused to pay it because they said, well, it was too easy. You fixed it in 5 minutes. I said, yeah, but it took 5.5 hours to get there to fix it in 5 minutes and all of that. And we battled that, and that got worked out satisfactorily. But the point is, sometimes you as a testing laboratory, as a failure analysis laboratory, have to receive the data and give it the appropriate weight. Sometimes the facts lead to the conclusion more than the backstory leads to the conclusion. Is that your experience in your professional life as well?
Yes, you have to have an open mind. One of the things I say until I'm blue in the face here in the office to all my folks is, think of us as Switzerland. We are Switzerland. We are the neutral party between warring factions. And in our world, the warring faction is often the OEM on one side and the EMS company on the other side. And one thinks it's the defect.
All pointing at each other.
Yeah, all doing this, blaming each other. And so we're brought in as the consultant to try to resolve the dispute. And one of the things I sometimes ask in an initial meeting is, if we do your failure analysis as you have spelled it out, maybe you have a written statement of work, or you've got a bill of particulars saying you want to do this, 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 this. If at the end of that we come up with no trouble found, or Doc Brown, trouble not found, is that a good thing or is that a bad thing? If we deliver that information to you, will you be relieved or angry? And how they answer that question is very indicative of the risk level of that engagement. If they say, I'll be relieved or I'll be happy because I can then check that off my list, eliminate that portion of my fishbone diagram and move on to other things. Maybe instead of a hardware problem, I have a software problem. Then I'm relieved. If, on the other hand, they're evasive or coy in answering that question, then that's a yellow light. That's a caution flag, because that tells me they're looking for me to find a solution. And like your customer who said it was too easy, I'm afraid they're going to say at the end, when I deliver a similar size bill, oh, well, you didn't find my problem, therefore I don't owe you anything. No, that's not how it works. You're paying me for my expertise, and on the basis of my expertise, this is what I can conclude. This is how we arrived at these conclusions, and here's the test data or the imaging data or whatever to back that up. Yes, you do owe us for our time.
Well, it's funny, when we go to a testing laboratory and they can't find the problem, we think we don't owe them money. But if we go to the doctor and they run a battery of tests and they can't find the problem, we still owe them money. There's no discussion there, right?
There you go. I use that analogy all the time. There's, when you're ill, oftentimes you go to a primary care physician. If the illness is more complicated, then frequently the PCP will refer you to a specialist. We're the specialists. We're the guys that typically aren't advertised. People
You're
have
the neurologist,
to
the cardiologist. Yeah. In
we're the
scenario.
neurosurgeon, and we're not out front, but those who know where we are, and they know how to find us and know how to refer these problems to us. So once you're in our lab, and we're engaging, and we've gone through the preliminaries, you're on the clock, because we're offering you our time, and we do expect to be compensated for that.
With the push toward miniaturization, a huge push right now toward miniaturization, and I'm thinking as an example, ultra-high density interconnects, UHDIs, how has testing had to keep pace with smaller components and denser circuit layouts, considering that a lot of times you have to touch everything, make contact with it in order to test it, at least for in-circuit testing type tests. How has that landed in your world?
It makes it all the more challenging because the traditional methods often don't work. ICT, for one, on some of these, cell phone boards, for example, or anything smaller than that, you have nowhere, have nowhere to put a fixed probe on a board to test it. So you end up resorting to non-contact methods. JTAG boundary scan being the most prominent example. As long as the board was designed with a JTAG chain built into the board, then you can devise a test, a non-contact test that will in part evaluate that board. The other way we address that is often with hybrid methodologies or mixed methodologies, where we may employ flying probe for a portion of the board, and automatic X-ray inspection for another portion of the board, and maybe manual inspection or CT scanning for yet another portion of the board, an inaccessible portion, looking at things like through-hole fill, for example, or particular components that are not accessible by any other means. You might have to do some sort of a manual inspection there to verify solder joint integrity. And that again gets back to education. You tell the customer it's not totally accessible by conventional means based on our analysis of the board. Here's what we recommend. We can do this, we can do this, we can do this. We can do flying probe, we can do AXI, we can do boundary scan, we can do power up testing of certain logic devices and certain voltage regulators. We can feed in certain voltages and measure output voltages and record that data for you. So it's a combination of things. X-ray and flying probe is a very common engagement.
When it comes to testing, there's automated testing, there's manual testing, and now there's AI blended into those things. I interviewed someone on the show yesterday who builds inspection systems that really rely heavily on artificial intelligence. And to use her words, their CEO's words, they offer two models. They call it Copilot and Autopilot. Copilot can be used where they integrate in AI in manual methods. So if they're looking digitally at something through a microscope or some type of digital lens, the AI will produce a message on the screen saying pass or fail or whatever the criteria is, and then the operator can verify that. And then there's automated methods like AOI type machines that will just do that automatically without the operator seeing that in real time necessarily, because it happens so quickly. Can you explain the role of automated testing with or without AI, but particularly with AI, and how it compares to manual testing and where one may be more appropriate and or more accurate than another?
Well, number one, automated testing in our business has existed for 35 years. It was very crude back in the late 80s, early 90s when the early AXI systems were introduced, but it existed just the same. I would say from then until now, the evolution or the improvement has been in increasing the automated decision-making factors in the systems, the refinement of the algorithms to screen out most defects, and reducing the workload on the human element, having to go through image after image after image to determine good from bad, to the point now that process has been significantly shortened. But there is still a judgment factor. AI has not eliminated the judgment factor. So to your colleague's comment, where it's a combination, kind of a hybrid situation, a mixture of automation and human intervention, I would agree with her on that and say that's very similar to where we're at today. We're not ready to let go yet, and Chat GPT coming out a couple of years ago only focused attention on things we had been dealing with anyway, which is we deal with algorithms. I mean, they don't write our test reports, but they present us with images which say, this is a defect. This fails IPC A610, class 2, class 3, whatever the criterion happens to be. But still, a trained human trained in that standard has to make the final call. The other one, there are still disputed areas. A very significant disputed area is voids on thermal planes beneath devices. IPC does not have a numerical criterion for acceptance the way they do for voids on BGA balls. On BGA balls, it's 30%. That's the threshold. However, beneath the QFN or some other device, it is the judgment call. It's left to the determination of the end user whether the voids shown constitute a reliability issue or not. And it's put back on them. And there's lots of raging debate within IPC as to whether that's appropriate or not. And we have some customers who will say, no, we don't accept that. We want this numerical value. And we say, fine, you're the customer. We will go by that. And everybody in between. But it's where the discussion is right now as to what constitutes reliability, what connotes longevity, what connotes an acceptable product, not only when it goes out the door, but will it last in the field in a harsh environment 6 months from now, a year from now, 2 years from now, whatever the case may be.
Here's one question. We're starting to run out of time, so I'm going to ask you just a couple more questions. And this question I was excited to ask you because we've emailed each other back and forth, and I sent you kind of a preview of some of the questions. And a couple of the questions you actually provided written answers to because it clearly touched the button with you. And I love your answer here. The question was, what's the process like when your company is called to troubleshoot a quote-unquote high-profile failure? And can you share any insights from notable cases? And then your reply was lots of hotel bar stories here. So you and I, let's just kind of fantasize. We're sitting in a bar over a couple of cocktails, and you're telling me the story. You can keep the company names obscure to protect the guilty or innocent in this whatever case. But can you share an anecdote where even though you self-declare that you're agnostic, Switzerland, what's happened in the case of when you're involved with a really high-profile failure?
I'll tell you one story. I chuckle about it now, but on the day that it happened, I was not very happy. Customer shows up at our back door with a large module they would like to have CT scan because it experienced a field failure. What they neglected to tell us was that when the field failure happened, the product ignited and burned to a crisp. So what was delivered to our back door was basically a frame containing ashes inside of it. And they were asking us to x-ray this and tell them why it failed.
Wow.
And I told the customer, you want me to put this in $1 million CT scanning system and have ashes blown all over the working parts of that machine. And why would I do that? Well, it's contained within the packaging. It shouldn't cause a problem. And what qualifies you to say that? And oh, by the way, the answer is no.
Well, you just add $1 million to the price. That way, you can get a new CT scanning machine.
Probably two. You've got to account for inflation.
That's true.
And
yes.
And people do that. They'll bring us stuff where you've had a massive short on a board or a massive short somewhere else, it obliterates the evidence. And yet they think that magically we're going to be able to reconstruct what happened.
They've watched too many episodes of CSI.
Yeah. So we get stuff like that, and it was probably 9 months or a year ago that this happened, and it's kind of funny to think about now. But that day, it was kind of the cap of a rough day, and I'm afraid I took it out on the customer.
Yeah, yeah. You incinerated right in front of them. Last question, Rob. If I am a potential customer, and I'm calling around various failure analysis labs or testing laboratories, depending on what I need. If I'm working with a competent company, what types of questions should I be prepared to answer? How do you, A, vet a potential customer, and B, ensure that you're asking the most appropriate questions so that you can deliver the most appropriate answer to those questions?
Well, the answer applies not only to independent testing laboratories, but also to testing departments of any manufacturing operation, so any EMS company. How do you maintain your equipment? How is it calibrated? To what standards? What frequency? Who does it? What are their qualifications? What's the chain of custody? What is the line of certification? To what standards? Show me the data. Are there up-to-date calibration stickers on the machine? I was once in a CM where there was an ICT machine on their production floor, and prominently displayed on the front of the machine was a sign which said calibration not required.
Okay, that's easy.
Yeah. The next question should be, on whose authority are you able to hang that sign? Which of course they couldn't answer. Yeah. So we spend a lot of money on maintenance contracts, calibration contracts, service upgrades, software upgrades. And everybody should do that. We're the last bastion. I mentioned we're Switzerland. We're often the final authority. So we have to be able to document what we do and provide evidence that the documentation comes from a system that is properly maintained and is up to snuff. Everybody should do that.
I feel for you when it comes to calibration and standards. We're not a laboratory. We're an equipment manufacturer, and one of the various pieces of equipment we manufacture are ROS testers, resistivity of solvent extract testers, to determine the bulk quantity of ionic contamination on an assembly. And we also sell cleaning machines, and we sold a cleaning machine to a major medical manufacturer. They were building implantable defibrillators and pacemakers and things like that. And they didn't want to buy a tester, but we told them, if they buy the cleaner, we'll do we'll do periodic testing for you. Just as a courtesy, and we do that a lot for our customers. And they said, okay, fine, we'll send you some test product. It's not real product, but we just need to qualify your testing procedure, and we'll send a couple of guys from our QC department or whatever. It's like, okay, that's fine. And so they came over, and I ran the test, and they said, we're just flies on the wall. We're just going to monitor how you conduct a test before we send you actual production stuff. I said, okay, fair enough. So first they asked, are you going to calibrate the machine? So yeah, we'll calibrate the machine before we conduct a test, which we did. And we used a NIST certified calibration solution. They looked at the certificate on that. It's like, okay, fine. And they saw the calibration procedure. They were happy with that. We used a hydrometer, which had a calibration tag on it, and they were happy with that. And then one of the things that we need to know to quantify the contamination level is what's the square area of the board? Length times width times 2, right? And I got out a ruler, and a stainless steel ruler, and measured the length of the board, the width of the board, multiplied that by 2, added a percentage for component area, entered that into the computer, and they said, "Oh, wait, we need to see the calibration sticker on the ruler." I'm like, "What?" And seriously. And I'm like, what? I've never heard of that. I mean, can we just agree, this looks reasonable? And I explained to them that even if the ruler was off by 50%, the number is still going to be pretty accurate, because we're measuring, parts per million, and that area it's just not going to be a big deal. And they're like, no. So he says, we stop it right now. We can't even test the samples because your ruler's not calibrated. So I went to some instrument store and I bought a calibrated ruler, which was basically the same ruler I had. It just had a sticker on it. And the thing that I found unexplainable, I started laughing when I saw it. It had an expiration date because, those little lines move. they drift on a ruler over a year. But so every year, we did this for several years for this customer, and every year we had to buy another $100 calibrated ruler.
And 1 minute after that expiration, anything measured by that, if it's flying, it just starts falling from the sky.
It's falling from the sky. Yeah. Stay under an overpass because planes are falling out of the sky.
Gravity asserts itself, and
exactly
reversion to the mean.
Well, I would imagine that's an extreme example, but that's probably kind of your world, right? Of standards and calibrations and things like that, not just from the customer, but your equipment has to be calibrated and has to meet certain standards.
we have aerospace certifications like AS9100, and part of that is maintenance of any measurement equipment. So not only the testing machines, but also the instruments to back them up. So oscilloscopes, DVMs, things of that nature. Even temperature and humidity controls in our facility have to be calibrated and maintained. So it's a big deal.
Well, Robert Bogusky, Chief Cook and Bottle Washer there at Datest, thank you so much for your wisdom and your sage advice, and for sharing kind of a day in the life of a test engineer and a failure analysis company. I appreciate the advice that you've shared with me, and more importantly, my audience. And for my audience who would like to know more about Datest, if you're watching this episode on the Reliability Matters YouTube channel, just look down, and in the show notes, there will be a link to the URL of Datest. If you're listening to this on your favorite podcast app, regardless of what podcast app there is, just go to the app, look at the show notes, and that information will be there as well. Well, Rob, thanks for spending the last hour or so with me. I really appreciate, I always enjoy talking to you, and I really appreciate the expertise that you've shared with me and my audience.
My pleasure, Mike. Great to be here.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And a special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikeconrad.com. Just remember, that's Conrad spelled with a K. To learn more about the podcast, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.